Hello everyone. This tutorial video will give you more information about how to start and be successful with Lab 1. I hope that you've all watched the video tutorial for creating a positive cloud count. As I note in this title here, the Canvas page in the video is a little different because I updated the actual Canvas page, but the instructions in the video are still sound. So please, if you haven't watched it yet, go back and watch the video tutorial for creating a positive cloud account. This video focuses specifically on how to get started with Lab 1. So the best way to get started is just to click on the assignment Lab 1. When I wrote this assignment, I decided to give students three choices on which data they want to analyze. So if you're interested in geosciences, physical sciences, etc., you might want to analyze climate data. If you're interested in health sciences, you might want to analyze health data. And if you're interested in finance or economics or business, you might want to analyze salary data. Once you pick your data set, you're going to be using it all term. And the data set you pick determines which lab you select. So for this video tutorial, I'll use Climate Lab 1. Just go ahead and click on the assignment, and it takes you to a file on Google Drive called Climate Lab 1 Template Version 2. Each of your labs has two tabs. There's a Code and Output tab and a Report tab. You work through the Code and Output tab all the way until you've completed it, and that will give you the information you need to complete the report. When you submit your assignment, you will submit both the Code and Output portion and the report portion. There is a lot of information in these labs. Since this is an online course, it is your responsibility to read it carefully and work through it. I'm going to give you an overview and an introduction, but I'm not going to go into all the details. So please read carefully, and if you have questions, you can definitely lead them in the discussions. When you open your lab, it will take you to the Code and Output page. There's a general lab instructions, which is what I just mentioned, and then the lab is divided into a series of steps. The first step is to always make a copy of your lab so that you can update it and eventually download it and submit it. This template is here for all students to make a copy, so itself is not editable. The first lab has some questions about you, and then it gets into the analysis piece. So since this is our first lab, it will include a link to the tutorial that I'm making right now and also give you step-by-step instructions. And we are going to go through these instructions together so you can see how it works. So I've watched the YouTube tutorial that I'm talking right now, and now I'm ready to go to Posit Cloud, which you have already done, and you have already created an account. So select that account. If you do see this window, choose Posit Cloud, not Posit Connect Cloud. Hopefully you already have your workspace if you followed that other video, but if you haven't, you click here on New Project and select New RStudio Project, and it's going to deploy and launch, and that takes a minute, so I'm going to pause the recording. All right, the project has launched. We check our lab, and we see that we've completed step 2, created a new RStudio project, and I'll update this to spring 2026. And the project is deployed. So let's save it as stat243z spring 2026, and I'll add online because this is my online class. The third piece is creating a new R script. So you click here on that green plus sign and select a new file, R script. And we want to save it. So click the anachronistic save icon here, and let's call this stat243z lab 1. As the previous tutorial showed you, the programming environment here has 4 windows. This blank window on the upper left is where we write all our script, or in your case, you will be copying and pasting code. The lower left window is called the console. This is where the script is actually run and the output will be produced. The lower right window is a combination of with a number of tabs. The Files tab has all the files. Notice it has this R script that we just created. And when you produce images, it will also show them in the Plots tab. And the upper right window is the environment, which shows you which variables are stored in your cloud environment. All right, we've completed the third one. We are now on to number 4. So to complete your labs, especially the code and output, all you need to do is anything written in this font is going to be copied and pasted into the R script. So select it, copy it, go over to your R script and paste it right there. Notice since it has hashtags, it's a comment. It's just for humans to read, and it's in light green. Some Macs don't change the color, but on a PC, it will be light green. And you can save to make sure that your script is updated. So I'm going to go ahead and change that to my name. It's always a good idea when you're writing script to put a date there. I'm recording this on the 28th. And here's the title of this lab. We hop back. We have copied our first code in, but we haven't run any analysis because we don't have any data yet. So the next series of steps, 5, 6, and 7, will walk you through how to get the data downloaded to your computer and then uploaded into your cloud workspace. Remember that Posit Cloud and RStudio all runs on a cloud server, so it cannot read any data that's on your computer. So you need to download it to your computer and then upload it into the cloud. So follow the steps here in your lab. First, we're going to click on this link, which opens the climate data in Google Sheets. Without changing anything, just go to File, Download, and make sure you download it as an Excel file. Now, I use a PC, which makes it very easy for me to find where this file is saved. If you use an Apple or a Mac, it may be a little more difficult, but then again, you may be more familiar with how to find it. Now, I want to point something out to you. When I've downloaded this file and I look at it in my folder, it has a little, oh, you can't see that. Let me change where I'm sharing. Okay, I've downloaded it to my folder. It has a little 1 in parentheses, and that's because I've already downloaded it. If I were to download it again, which is what I'm doing now, and refresh the view, now there's a climate data 2. This may not seem like a problem, but it will break all of your code in RStudio if you have this 1 or the 2. So I'm going to pause the video. I'm going to find my old original file and clean it up so this file has the correct name, and then I'll start the video again. So now you can see that I've fixed the name of the data set downloaded. It is just climate data. There's no parentheses 1, there's no parentheses 2. And that's very important. If your file has any name other than climate data, or maybe health data, or salary data, it will break the code in RStudio. I'll go back to my web browser. We've downloaded the data, so we can close that Google Sheets file. You must save it with this name, as I said. Here's that error. Now we'll go back to RStudio, find the Files pane, and click Upload. So over here in the Files pane, there's the button that says Upload. So we're going to upload files to server, and we leave the target directory alone and choose File to Upload. There it is, climate data. It's got the correct name. Double click it. and click OK. And now you can see it's been loaded into my cloud server. So now this data file is in the cloud, and I will be able to access it and use it in R with one additional step. We've completed number 6. So to get it all the way in to where you can actually analyze it, we have to click on the name and select Import Dataset. So over here in the Files pane, click on the name Climate Data and select Import Dataset. You will very likely see this Install Required Packages window, so simply click Yes. And while it's doing that, I'm going to note that it said you may be prompted to install packages. Click Yes to have RStudio install them for you. It's going to run a bunch of red output here. Don't worry about that. That's just R working and installing all the specific code that it needs to successfully install or upload, import this file. Once it's done, you'll see this sheet. Don't change anything, just click Import. And now over here in my environment, I see data. It has climate data, which has 193 observations of 6 variables. Remember, an observation is the individual that's being measured, and the variables are the different pieces of data that we are measuring. It shows you what the data set looks like. It's good. It looks the same as it did at Google Sheets. And now click that little X next to climate data. It doesn't delete the data. It just closes the view and brings you back to your script. It takes a while to get this far. But we have successfully imported the data. We are ready to conduct some data analysis. So we are on to step 4 for lab 1, which is an overview of a data set. Always a good place to start when you're analyzing data is simply an overview to see what you have. As I mentioned at the beginning, the labs have 2 parts. They have the code and output and the report. The code and output is what you do first. Once you're done with that, any question that provides information for the report will have report highlighted next to it. So question 1 is going to give you information that goes into your report. Question 2 is going to have information that goes into your report, etc. Delete this. Okay. So to run an analysis, often what we do as programmers or statisticians is we type code in here. But in this lab, I'm just asking you to copy code. So copy anything in this font, copy it. Usually I use Control-C or Command-C, but you can use the mouse. Copy it, paste it here. And then to run it, make sure your cursor is on the same line and click Run. And down here in the console, it ran that code and it gave you this output. The names of the variables are continent, country, city, April temp, precip, and latitude. Copy this back over and paste it where it says list the variables. And you've answered question 1. Let's move on. Let's find out how many cities are in the data sets. So we're going to use this code. So select both. Whenever you copy a block of code, make sure you copy all of it. This is one of the common frustrations, is if you only copy part of it, it may not run what you're expecting. So copy this, paste it in. And again, anytime you're going to run code, you should highlight, if it's more than one line, you should highlight all the lines you want and run them all at once. So we're going to run the current line or selection, and we've created a variable. Notice over here we have a value n, and n is equal to 193. That's the number of cities in the data set. There are 193 cities in the data set. Continue answering questions like that. What continents are represented in the data set? Copy this code. Run the code. it gives you the names of the data set or of the continents. And then copy this and move it back to your code and output section. That was the data overview, the data set overview. Now, if you're working on the health data or the salary data, it'll be a little bit different. I'll still ask you what the variable names are. I'll still ask you how many observations. I may not ask you what the continents are, but I may ask you what the age groups are or what the job types are. If you're watching this video before we've talked at all about qualitative data analysis, that's fine. Or maybe you've already watched the lecture video about how to construct a frequency table. So that's what we're going to do here. Step 5 is all about qualitative data analysis. Question 1, which will go into the report, construct a frequency table to count the number of cities measured on each continent. Report your table below. So here's the code. So I'm going to copy that code, paste it in here, run it, and it produces a table that's very poorly formatted, but it does have Africa, there are 15 cities. Asia, there are 29 cities. Europe, there are 60 cities, etc. So I can copy all of that and paste it back in the Climate Lab, paste the table here. So the easiest thing is just delete that and then paste the table in. Unfortunately, the formatting is a little off. So if you want to adjust the formatting, you can do that. So for example, we could adjust the formatting like that. And now it's a little easier to see in Africa, there are 15 cities, etc., etc. This is how you complete the labs in the code and the output. It's important to read the questions carefully so you know what you're doing. Copy the code correctly. If you forget to copy all the code, it's going to create an error. I'll show you that on the next one. Copy the output back in. These questions all go into the report, but here in question 2, this question I want to see in the code and output section, but it's not actually going to show up in the report. So it gives you a chance to construct a relative frequency table. If you've already learned the difference between a frequency table and a relative frequency table, you'll remember that a frequency table counts the number of observations, and a relative frequency table looks at the proportion of observations, which is simply the number divided by the total. So I'm going to calculate now the relative frequency table, but I'm going to show you what happens if you don't copy all the code correctly. Let's suppose that I copy only up to the division side, but I forget the n. And if I copy and I paste that in and I try to run it, it didn't give me anything. In fact, it gave me a plus. And I'm like, what does that plus mean? The plus is still there. It did show me a little X, which is helpful. If you see a plus in the output, something went wrong. So here's the pluses. Basically, it means that the code is not complete. So in order to get to fix this, first press the escape key to interrupt the code. So I'm going to press the escape key now. And when I do, oh, you're going to be in this console, press the escape key. And when I do, it changes from the plus to that little arrow. And now I have interrupted the code. Then go back and check your code to see what went wrong. So I say, well, what's wrong here? The easiest thing to do is just to delete and recopy the code from the lab. So I'm going to go up here and I'm going to delete that. I'm going to go back to the lab and be a little more careful when I copy this time. And now when I run it, it gives me a relative frequency table. which then I copy and I paste back into the lab. There are some other possible errors. So maybe I copied it all correctly, but when I went to run it, I didn't highlight it all correctly. So maybe I didn't highlight the whole thing. I only highlighted part of it. That's going to give the same, potentially the same mistake, right? So it had the plus. I have to hit escape, and then I go back and I make sure that it's all copied. Another mistake that happens a lot is if your code relies on something that came before it and you didn't run the earlier code, you often get an error. So let me give you an example of this. Let's suppose I forgot to run this n equals length of climate data city. When I run this, it stores n as a value, but if I didn't run it, then it doesn't have it as a value there. R does not know what n equals, so it cannot use it in any later code. Now I try to make a relative frequency table, which uses climate data $continent divided by the number of rows in the table, and it gives me an error because it has not found the code. It has not found the object n. Gives me an error because R does not know what n is. The easiest fix is to go back earlier in your code and start rerunning code. So I'm just going to go back up all the way up my table, and I'm just going to start over. I can even highlight everything down to what I want. And now when I run it, there was a line in here where n equals length of climate data city. So now R knows what n is, and it doesn't give me an error. So one of the common errors is to forget to run a piece of code that R needs, and later you try to run something and it gives you an error. Moving back to the lab, you're going to continue copying and pasting. Here's an example of creating or code that will actually create a visual. By the way, in the climate lab itself, it's split over 2 lines, but the code itself is actually just 1 line. So again, you have to be careful to copy not just the first part of it, but all of it. Because if you copy just the first part of it, you're not running the full code. So copy all of it, paste it in your script, and then run it. And what happens is it creates a plot, and over here on the right, it changed from the files view for the plots view, and now we have a bar plot of the number of cities per continent. If I don't like the way this looks, I can scale it bigger. I can just grab here and drag up or over and drag up and make it a little bigger. Your plots should have titles. They should have labels on the axes generally. Number of cities per continent, it's very clear that this vertical axis is the number. I would like your plots to be formatted nicely visually. However, there are some challenges. For example, the long name South America gets cut off. This is not something you need to worry about for your report. If you give me a picture that looks like this, that looks like this, I'm not going to be very happy because I cannot see the vertical at all. So it needs to be big enough to actually see what's going on. But if some of the text formatting gets messed up, don't worry about that. That requires a lot more coding to get it right, and this is not a coding class. Once you make the plot, you can generally just right-click and you can copy image. It might be a little bit different on a Mac, You can also do export and copy to clipboard. I don't want you to do a screenshot because that loses detail. Similarly, over here with the output, I'd rather you not do a screenshot. It's okay if you do it for the code and output section, but definitely not for the report section. So let's copy this and then come over to the lab, delete this box, and paste in the bar plot. And there we go. And like I said, the North America and the South America got cut off. That's something you don't have to worry about. And so it goes. Here's a long chunk of code. So you make sure you copy all of this together and run it all at once, and then paste in your output. And then here's some quantitative analysis. So again, make sure you copy all the blocks of code at the same time and run all the blocks of code at the same time. I'm going to leave you to work through the rest of this part on your own. Let's go and talk about the report now. So once you finish the code and output, the information will be there, but it's not very useful for anybody other than a statistician or a statistician who likes to code. So instead, you need to create a report. And so each of these labs imagines that you are an intern, either at a climate research lab or at a medical clinic or at an economic research firm. And you will be taking your output and formatting it and putting it in context and putting it in full sentences, complete sentences, etc., in a report for your supervisor to read. The reports have information to help guide you. Anything inside of a bracket, you eventually delete. I don't need to see stat 243Z, report 1, etc. That's information for you. I don't need to see this sentence. That's information for you. So you will eventually delete all of this. You can leave introduction. It's not in brackets and it's a title. And you will introduce your report with the scope of the data, the variables of interest, etc. Here's an example that uses salary data instead of climate data. Data overview is the second section, and it corresponds to the output that you created in step 4, dataset overview. For example, what are the variables in this dataset? Your output gave you 6 different variables, and the report says you should describe the variables included. I don't want you just copying and pasting. I want you writing something like, this data set includes variables that list the continent, the country, and the city of interest, and also variables for the maximum temperature in April and the total precipitation in April, and includes a variable that describes the latitude of the city. So basically, you take this brief output and you put it into human language. The next section describes key qualitative variables, and that corresponds with the qualitative data analysis. Here's a frequency table. Here's a bar plot. The report says, describe simple ones like latitude with summary data, but you should include tables and bar plots for more complicated variables like continent, and then answer the following questions as part of your explanation. I do not want you to just copy and paste a table that looks like this. This is not well formatted for a report. Instead, what you could do as you are doing your work, is you could go over here and you could insert a table, and you could say, you would say Africa, Asia, etc., and then the number of cities, etc. And so it would just be better formatted than just output from the R code. And you continue through that with all the variables and then write a conclusion. Once you finish the code and output and you organize it in your report, you are done with the lab. You will download both the code and output and the report and upload them both to Canvas. So let's go back to the assignment. right? So you will see the student version, you will see the start assignment, and then you will download both and upload both to the Canvas assignment. If you have questions, you can ask them in the discussion board. There is a thread for lab questions. Just say I have a question about lab 1. I will be checking the discussion board 2 or 3 times a week to answer questions. And one last piece of support for you. I have taken student work from last term that's a really great exemplary report and uploaded that. Now, I didn't upload the code and output part, but this report is a very, very good report. It shows how the student used good human natural language to describe things, visuals that are easy to interpret. I like how they created the table here. It doesn't have to be the way I showed you. Some visuals right there. There's a histogram. Um, one thing I will say is as you go through these labs, there are 4 labs and they build on each other. So each lab contains everything from the previous work. So if you look at this exemplary report, you will notice not only does it include this initial analysis from lab 1, sorry, it's not loading. Okay, I switched over to the actual PDF. As I was saying, this is the report for lab 4 for this student, and it includes everything from lab 1, but it also includes pieces from labs 2, 3, and 4. So as you look through this, if you use it to help you, you'll notice after the ethical considerations, there's no conclusion. It moves on to lab 2. So don't be worried if there's portions in here that you haven't seen yet. This is here just as an example to help you see what a really good student report looks like. You can work on it your own way. I don't want you to just copy this process, but it'll be there as a resource. All right, that's all I can think of with the lab. Um, Again, you find the first lab in the assignment here. You select which data set you want to work on, follow the instructions to create a RStudio workspace and an R script and to upload your data, and then complete the code and output piece, and then use the code and output to write your report, and then download both the code and output and upload them to the Canvas assignment. Thanks for watching this video. I know it's a little bit long, but it'll get you set up to be successful on all 4 labs throughout the term.